You use it every single day. It connects your headphones, your car, your keyboard, but have you ever really stopped to wonder how Bluetooth actually works? Well, we're about to pull back the curtain on the invisible technology that kind of holds our entire digital world together.
Okay, so let's just dive right in, because let's be honest, it really does feel like magic, doesn't it? You tap a button on your phone and boom, music just streams through thin air. But it's not magic, it's just incredibly clever engineering. And by the end of this, I promise you'll get exactly how that brilliant engineering pulls it off.
At its very heart, the simplest way to think about Bluetooth is as an invisible wire. It was invented for one simple reason: to get rid of that tangled mess of cords and cables that used to chain all of our devices together.
So when you connect two devices, let's say your phone and a speaker, they create this small, personal network. It's called a Piconet. Just think of it like a private conversation bubble just for your gadgets. It lets them talk to each other without anybody else being able to listen in.
All right, so how does this invisible conversation actually happen? Well, it all happens with radio waves. And here's a cool fact: while we can't see them, radio waves are actually part of the exact same electromagnetic spectrum as the light we can see. They're just a different color, one that's totally invisible to our eyes. These specific radio waves have a wavelength of about 12 centimeters. And what that means is they're long enough to easily pass through obstacles, like the walls in your house. It's pretty much the same reason your car radio still works perfectly when you drive into a garage.
And this is where it gets really, really brilliant. Every single piece of digital information, every note in a song, every word you're hearing right now is broken down into a super simple language of ones and zeros. Bluetooth communicates this by rapidly switching between two slightly different wavelengths, one for one and one for zero. It's just like a traffic light switching from green to red, over and over.
So just how fast can it switch between these ones and zeros? The speed is what makes your audio sound so seamless and not all choppy. We are talking about 1,000,000 times.
Yep, that's right. Your phone's little antenna is switching between those 1 and 0 frequencies about 1,000,000 times every single second. That rapid-fire conversation is what builds a smooth, continuous stream of music right there in your ears.
But as elegant as this system is, it has to overcome a huge challenge. Bluetooth isn't having this conversation in some quiet library. No, it's trying to talk in the middle of a very, very crowded room. You see, the radio frequency band that Bluetooth uses, 2.4 gigahertz, it's basically an unlicensed public space. It is absolutely packed with other signals from countless devices we use every day, all shouting and competing for the same airwaves. So this is the big question, right? With your Wi-Fi router streaming a movie, your microwave nuking some leftovers, and your neighbor's own Bluetooth devices all chattering away, how on earth does your headphone signal stay perfectly clear and not get completely drowned out in all that noise?
Well, the answer is an incredibly clever trick called frequency hopping. This is the secret sauce that makes Bluetooth so tough and reliable, and it is the entire reason your music stays crystal clear.
The secret to this whole solution, the key to this entire invisible dance, it all comes down to one number.
1,600. That's how many times your Bluetooth devices jump between different frequencies every single second, just to avoid interference. It's an absolutely mind-bogglingly fast dance.
So here's how it works. When your devices first pair up, they secretly agree on a random, synchronized hopping pattern across 79 different channels. So if they happen to hop to a channel that's all noisy because of your microwave, they don't panic. They just spend a tiny fraction of a second there, and then poof, they hop to the next clear channel in their secret sequence, keeping that connection totally strong. And on top of that, the data isn't one long, continuous stream. It's chopped up into these tiny little packets. And each packet has a digital address, kind of like a mailing address on a letter. So even if a packet from your neighbor's phone happens to reach your headphones, your device sees the wrong address and just ignores it. Simple as that.
Okay, so now that we've kind of unpacked the technical wizardry, let's explore the really fascinating history of Bluetooth and maybe tackle some of the common questions people have about using it every day.
This technology feels so modern, but it actually got its start over 30 years ago at Ericsson, with a goal that I think we can all relate to: getting rid of tangled headphone cords. It took a decade of development, but the first commercial headset was finally ready back in 1999.
And what about that weird name?
Well, it was actually suggested by an engineer at Intel who happened to be reading a book about Viking history. See, the whole point of the technology was to unite different devices and communication standards, just like the 10th century king, Harald Bluetooth, was famous for uniting all the scattered tribes of Scandinavia. Pretty cool, huh?
So what about some of the common worries? Well, when it comes to health, Bluetooth signals are extremely weak. We're talking about 1,000 times weaker than a standard cell phone. And for security, modern connections are all encrypted. Really, the biggest risk is usually just annoying spam messages, which you can easily block by just setting your device to non-discoverable when you're in public.
And this brings us right back to where we started. That feeling of magic is definitely still there. But now, hopefully, we can appreciate the incredible science and really clever problem solving that makes it all possible.
So, the next time you pop in your earbuds and connect to your phone, just remember what's really happening. It's not magic. It's a breathtakingly fast and complex dance, a secret conversation, hopping between channels 1,600 times a second, all just to bring that sound to your ears. It is a true invisible marvel of engineering that we get to use every single day.